Okay, so now we move into some recommendations for research labs. Before jumping into the recommendations, I think it's important to discuss what is a device. The term device is ambiguous. It could be anything. In the classical networking space, we would have an axiom. We'd say that a device is a managed network element that performs network functions. It is managed still, even if only relaying operational state from sensors. So in my example before about if the device only has a temperature sensor, well, it's still being managed. And so it's, it still can be considered as a managed network element. The corollary to that, extending it to the quantum networking realm, is that a quantum networking device is a managed network element that performs quantum networking functions. So examples of this would be a laser or a detector, or prepare module, or measure module, optical switch, for example. Oftentimes when saying what something is, it's helpful to say what it's not. And so what is not a device? Well, I think it's fair to say that various components on an optical table which are assembled to perform a quantum networking function are not each of themselves a managed device, right? So on the optical table, there could be mirrors and fiber cables and a variety of different components, but those individual components are not each of themselves being managed. It's the combination of them all, which is the managed device. And then now for the actual recommendation for the research labs and to whether or not to support YANG and NETCONF. This table is, let me explain this table. On the left-hand side, we have the rows, research lab device and third-party vendor device. So a research lab device would be a device that's being created by the research lab themselves. They're assembling the individual components to create a device. Whereas a third-party vendor device, of course, is a commercial off the product, or maybe not necessarily commercial, but it's by someone else. It's something that can be obtained. On the columns, we have how's the device being used? Is it meant to only be used internally, or will it have some external but limited use? Or is it expected that the device will be widely used, have broad deployment? Okay, now that we understand the rows and columns, we can dive in. In the upper left, we have, for research lab devices that are used internally only, the impetus for supporting NETCONF and YANG on those devices is subject to effort analysis. It's, what is the return on investment? If you're only using internally, perhaps you could get by with not having to have or implement the NETCONF YANG stack. If there's going to be limited external use, the story is similar, but now it's recommended. It would be recommended because you're asking others to use the device as well. It's not necessarily understood in all the different use cases that other deployments have. And it's possible those other deployments are themselves having existing systems. We mentioned in the previous slide about the EMS and NMS and SMS systems. They may have an existing system that's using NETCONF YANG, and being able to integrate the device into that system would be helpful to them. Of course, there's the notion of device drivers. So in case the underlying device doesn't implement NETCONF YANG natively, it's possible for a device driver to be implemented off box, for instance, by the controller or the orchestrator, to still work with the device. It may have to interact with the device's command line interface, which brings in the issues we mentioned earlier about the sequencing of operations, and there's complexity. Many times the CLI interfaces, I should have mentioned this before, but they're more human oriented, and so when you're asking for the device to present operational state, it may present it in the form of a table, an ASCII table, as the response, and so then it's necessary to do what's called screen scraping to try to extract what is the operational state. But it is complex to create these device drivers. But for those deployments that really wish to have or to assume that network YANG is being used throughout, it's possible to create device drivers to give that abstraction northbound. But then there's a case of if the device is meant to be widely used externally. Here, it's strongly recommended that the device implement the NETCONF YANG stack. Because it's being widely deployed, the return on investment, it's how much easier it would be for all the consumers or the clients that wish to interact with the device. It allows all those consumers to have an easier time to interact and manage the device. So that's the first row for research lab devices. And then we have third-party vendor devices. In the first column, for internal use only, this is not applicable because it's a third-party vendor device. It's already the case that it's being used externally, and hence that cell is not applicable. But if it's a third-party device that has a limited external use, so they've created a device, but it's not being used broadly, you wish to use it in your deployment, it's a reasonable request to ask the vendor to implement YANG and NETCONF. But if the intention is to use the third-party device widely, and it's going to have broad use, at this point, the recommendation would be to demand the vendor to support NETCONF YANG because of the broad deployment and how much easier it will be for you, your deployment to manage those devices is connected to how easy they are to work with. It's highly recommended to demand the vendors to implement NETCONF YANG.